My name is Brishgopal Bharadwaj, 17 BCE 2399, and this is the hardware part of our project, Home Automation. Now, as you can see here, the hardware part of our circuit is mainly comprised of three modules: the Raspberry Pi, the relay module, and the breadboard, which houses most of the circuitry. The Raspberry Pi is the governing component of our project, which controls the hardwares like the sensors. The sensors included here are two ultrasonic sensors, one for the control of geyser, one for the control of water tanks, one MQ2 gas sensor that gives us simultaneously readings of three different parameters: the smoke levels, the CO levels, and the LPG levels. Other than that, we have a DHT11 sensor which gives us the values of temperature and humidity, and we have here a relay module. The relay module is controlling the operation of this LED, which in our circuit is simulating two circuits. Once it is behaving as the geyser, and some other times it is behaving as a bulb that will be connected in an actual circuit. The Raspberry Pi controls all these components together via the use of GPIO pins that are being connected to the required places using some jumper wires. Now, moving on to the software part for the hardware. Here we can see this is the database for our circuit that is hosted on Firebase. It has a number of flag values, which it has a number of parameters that store the different real-time values generated by the sensors or recorded, and based on that our circuit performs some suitable actions. So without further ado, let's see our circuit in action. So first of all, I'll begin my circuit by giving the start command, and once that happens, our circuit first calibrates itself to ascertain the normalized values for the MQ2 gas sensor and the DHT11 sensor. These values, once stabilized, can then further be used in the calculation of the rest of the circuit. And as you can see here, the database has been initialized to its original form. Now, once the circuit completes calibration, it starts executing. And as you can see here, when the values are recorded by the gas sensor, they are updated in a real time here in the Firebase database. Also, you can see on the right side of the screen, there are some logs that are being maintained that help us to determine the current state of the circuit. Now, let's look at individual components of the whole project and understand their working in detail. So first of all, we'll move to the geysers, to the part of our project that's controlling the geyser. As you can see here, the database component related to that has 6 flags: distance, mode, notify, reference, state, and vigilant. The distance parameter stores the real-time value recorded by this ultrasonic sensor, which is computing the distance between here to that wall. And the method of computation is as follows. It sends out some ultrasonic sound pulses, which when reflected back from the wall come back to it, and it measures the time delay between the two transmission and the reception operations. From that, we can calculate the distance between the reflective surface and the sensor, and based on that, we update this parameter. The mode parameter determines in which configuration is our geyser circuit presently in. Our circuit provides two modes for the geyser circuit: the auto mode and the manual mode. In the auto mode, the circuit shows some level of intelligence, and based on the data recorded by the sensor, it determines whether the geyser should currently be in an on state or an off state. The reference is the referral value used by our circuit to perform various calculations, and using this value, we can compute the the distance that is in usual case, i.e., when there is no user in front of the sensor, and otherwise, when the user is in front of the sensor, this distance is expected to be less than the referral value. The last flag in our discussion is vigilant. Vigilant flag determines whether the circuit is paying attention to the values recorded by all these data in the circuit because of some necessities that will be explained in the later part. So let's see what happens when we switch on the state, when we turn the state from off to on. The change that I am performing in the Firebase, this will be done by the app component of our project, which will be explained in the later part. Once I turn the state to on, you can see the LED gets lighted up. This LED is here simulating the role of a geyser. Here in its place, we can connect any other component. But in our case, we are assuming it to be the geyser. Once that happens, we need to configure the geyser because our system won't run unless the reference value of the geyser is calibrated for the place where the sensor is installed. So for doing that, we change the value of the geyser component with the flag geyser. Once that happens, the reference value will be updated. As you can see here, it is updated in a yellow box. This yellow box indicates that the values are being updated. And once that happens, we can start recording the real-time value in the distance flag. Once that happens, the circuit starts making decisions. Now, as you can see here, there are many timers in our circuit and one of them has been activated, the timer 1. The timer 1 is recording the time for which the user is not present in front of the ultrasonic sensor installed in his bathroom. Now, why is that? With this value, we are trying to identify whether the user is present in front of the geyser or not. For example, if I stand in the middle of the wall and the sensor, then the distance between me and the sensor is lesser than the reference value. And due to that, as you can see, the timer has stopped. This indicates to the system that a user is indeed present between the sensor and the wall, and thus the geyser is being used in the way intended. But once I step back and the geyser and the sensor is again left to get the reflection back from the wall, the timer restarts. And the reason for that is now there is again the condition when the timer is left, when the geyser is left unattended in an on state. After some time, this timer will expire. This grace period, after the ending of this grace period, it means that the geyser has been forgotten by the user in an on state. And so when that happens, we'll display a notification to the user asking him whether this was a deliberate action or whether it was a mistake. And we'll ask him whether we should leave the geyser on or turn it off. As you can see here, the timer 1 has expired and now we are activating the timer 2. The timer 2 is recording the time for which the user has interacted with the notification or not. For example, let's consider 3 scenarios. First of all, we'll make this notify value as on. This implies that the user said, no, I really want to keep the geyser on. In that case, we can see the geyser has been notified that the user has responded with a value on, and now we are starting a third timer. The third timer will run for the next 1 hour, and it will during this phase we have turned off the vigilant flag that we talked about earlier. As a result, the system is not paying attention to the geyser component of our circuit. Why is that? Because it means physical interpretation of these values is that the user has chosen to keep the geyser on. There may be many reasons for that, but for our concern, it is that the user wants to keep the geyser on in an unattended state. So we are not paying attention to that part, and after 1 hour, the timer will expire. As you can see, the timer 3 expired, and now the timer 1 has started again with the vigilant value on. That means there is still no user in front of the sensor, and now the system is asking whether we should turn it off again, because 1 hour is quite a long time. And once that happens, if the user still says nothing and he does not respond to the notification, in that case we'll assume that the geyser has been left unattended, and once the timer 1 stops, we'll say okay, in that case we'll turn it off ourselves to conserve the electricity, because we know that geyser is one of the heaviest units installed in the home. As you can see, the timer 2 has expired. That means the user has not responded to the notification. In that case, we assume that the response should be off because we want to conserve the electricity. And thus, once that happens, the LED or the geyser has been switched off automatically. And now all the timers have been reset and the system is in the state in which it began the execution. This is the execution of the geyser part of our circuit. Now let's move on to the other parts that are presented by the system. The MQ2 gas sensor over here is providing us with three simultaneous values: the CO levels, the LPG levels, and the smoke levels. These values will be used to compute whether there is some emergency scenario in the house or not. The values are being measured in ppms, and usually for an ideal for a normal condition, the value is in around some 0.00 something ppms, and once the value exceeds a threshold value, it indicates that some serious problem is there. For example, if the smoke level crosses a predefined threshold value, it indicates that there is some kind of fire or some other smoke producing activities going on in the house, and thus it will cause an alert to our system, which will record this in a Firebase database in this section, and based on that, the app will give a notification to the user that will indicate it that something is wrong and they need to take the appropriate measures to correct it. Similarly, for example, if the LPG cylinder in the house is leaky, in that case, the LPG levels will go high, and once that happens, the system will again update these values, and that will result in a corresponding notification to the app that will tell the user that something is wrong with the LPG gas cylinder. This is how our system is protecting against such kind of scenarios. The third part that is offered by our circuit is the DHT11 room sensor. This sensor is recording the data related to the temperature and humidity of each individual room present in our house. Now, why is that data useful? If there are some smart appliances in our system, in the house, then these devices can communicate with our system to use these values to incorporate some other smart behaviors in their own systems. For example, the air conditioners or the other appliances that are installed in the house can determine whether or not to operate based on this data. Now let's look at the next part of our circuit that deals with the control of the other non-smart appliances that need just an on-off operation. For example, in this case, we are controlling an electric bulb simulated here by the LED. The LED is being driven by this relay module that is connected in between it and is acting as an electronically controlled switch. This switch is being governed by a trigger pulse that is being provided by the Raspberry Pi through this jumper wire. Now, let's see it in action. In the database, there are in the room stats under the room 1 category, there is a flag called bulb. There can be many such flags for each and every device that is intended to be controlled by our system, and they can be appended here. So when the user presses the on-off button in our app that will be presented after this presentation, the bulb flag will change its value from off to on as specified by the user. Once that happens, the corresponding trigger pulse will be transferred by the Raspberry Pi to the relay module, and the LED will be lighted on. Similarly, when I change the flag value back to off, another trigger pulse will be transferred that would result in the switch off of the LED. This is the procedure of operation of the relay module part of our circuit. The last part deals with the water level detection and identification of our system. The ultrasonic sensor, the second ultrasonic sensor present here is measuring the distance between the between the surface of water and the sensor in the water tank. Now we are computing a percentage of the tank that has been filled up using two other parameters, refmin and refmax, that are recorded here. These two will also be configured by the user. Once that happens, we can use these three values, the real-time distance value, the refmin value and the refmax value, to figure out whether the water, what is the percentage of tank that has been filled up by the water. If we find that as the time progresses on, the percentage is getting increased, we can send a notification to the user indicating that the water channel that provides water to the house has started providing the water. In some houses, actually, there is a feature, for example, in mine, that we receive water from some other water bodies, and this operation is periodic in nature. It happens every 1 or 2 days, and once that happens, usually we need to manually go and check in the water tank of our house whether the tap that is supposed to deliver the water to our houses is actually giving water or not. This way, that hassle has been removed. We can get a direct mobile notification that will tell us that the water tap has activated and now we are receiving water in our house, and then the related operations can be carried out by the people living in the house.